All right, example 28. Example 28 says the variables x and t are related by x is equal to 1 over t, and the variable z depends on x. Use this relationship to show that the differential x to the fifth d2z by dx squared plus, open bracket, 2x to the fourth minus 5x to the third dz by dx plus 4xz is equal to 6x plus 3 can be reduced to d2z by dt squared plus 5 dz by dt plus 4 z is equal to 3t plus 6. Hence, solve the equation to find z in terms of x. All right, so let's start out. We're told that x is equal to 1 over t, which is the same as saying t to the minus 1. Now, dx by dt is equal to minus t to the minus 2, or minus 1 over t squared. Now, dz by dx is equal to dz by dt times dt by dx. So dt by dx is 1 over dx by dt. So this is dz by dt times 1 over dt by dx, which is minus t squared. So this is minus t squared. So we could write this as minus t squared dz by dt. Let us find d2z by dx squared. To get that, we'd have to differentiate d by dt. So we differentiate dz by dt. And this is dz by dx multiplied by dt by dx. All right, so let's differentiate dz by dx with respect to t. So this is what we're differentiating. It's a product derivative. So it's leave the first minus t squared. Differentiate the second. We have d2z by dt squared plus leave the first minus t squared. No, sorry, plus differentiate the first. You differentiate the first, you're going to get minus 2t, leave the second, dz by dt. And of course, we multiply this by dt by dx, which is dt by dx, which is minus t squared. All right, so what we end up with, or we should end up with, is a negative times a negative is a positive, t to the fourth, d2z by dt squared. A negative times a negative is a positive, 2t cubed dz by dt. Now, substituting this into x to the fifth d2z by dx squared plus 2 x to the fourth minus 5x to the third dz by dx plus 4xz is equal to 6x plus 3. So if we substitute dx, substitute these values for the differential of z with respect to t, we're going to get x to the fifth. Remember, x is equal to t to the minus 1. So x to the fifth would be 1 over t to the fifth d2z by dx squared, which is equal to what? T to the 4 d2z by dt squared plus 2 t to the third dz by dt plus 2 x to the fourth, which is t over 4 t over 4 minus 5 t over 3 dz, which is minus t squared dt dz by dt plus 4xz, which is 4z over t, is equal to 6x, which is 6 over t plus 3. All right, so if we, well, let's expand to the right. We get 1 over t d2z by dt squared plus 2 over t squared dz by dt. Negative times a positive is a negative. And we get 2 over t squared dz by dt. Negative times a negative is a positive. 5 over t dz by dt plus 4z over t plus 6 over t plus 3. All right, this goes, then multiply everything by t. We're going to get d2z by dt squared plus 5 dz by dt plus 4z is equal to 3t plus 6. So we were asked to show that the differential equation is going to become this. Now what we have is a non-homogeneous second order differential equation. To solve, we need to first find complementary function, which is the solution of d2z by dt squared plus 5 dz by dt plus 4z is equal to 0. The auxiliary quadratic equation, and we have m squared plus 5m plus 4 is equal to 0. This is m, 4, 1 plus is equal to 0. So m plus 1 is equal to 0, or m plus 4 is equal to 0. So m is equal to minus 1, or m is equal to minus 4, are the solution of the auxiliary quadratic equation. So the CF is y is equal to, not y, z. Z is equal to a e to the minus t plus b e to the minus 4t. Next, we need the particular integral. It's of the same form as the f of x, so it's equal to at plus b. Our job is to find out a and b. Now dv, sorry, it's not y. I keep writing y. It's actually z. So it's z. Now dz by dt is equal to a, and d2z by dt squared is equal to 0. Substituting into this equation, which is a2 dt d2z by dt squared plus 5 dz by dt plus 4z is equal to 3t plus 6. Substituting in that, and we get 0 plus 5a plus 4at plus b is equal to 3t plus 6. So now we have 5a plus 4at plus, is this 4b is equal to 3t plus 6. So now we have 4a is equal to 3. This is the t coefficient. And so a is equal to 3 over 4. We also have 5a plus 4b is equal to 6, constant. And so we have 5 times 3 over 4 plus 4b is equal to 6. 4b is therefore equal to 6 minus 15 over 4. This is 24 minus 15 over 4. And so 4b is equal to 9 over 4, and therefore b is equal to 9 over 16. So y is equal to a, which is 3 over 4t, plus b, which is 9 over 16, is our particular integral. And now the general solution is y is equal to again, so old habits die hard, should be z. So this is z. So this is z. And so the general solution is z is equal to a e to the minus t plus b e to the minus 4t plus 3 over 4t plus 9 over 16. We need to get z in terms of x and not t, remembering that t is equal to 1 over x, because remember x was equal to 1 over t, and so t would be equal to 1 over x. So what we get is z is equal to a e to the minus 1 over x plus b e to the minus 4 over x plus 3 over 4x plus 19 over 16. All right, so the last example in the chapter, example 29, says use the substitution y is equal to x squared. Y is equal to x squared to show that the differential equation x d2x by dt squared plus dx by dt squared plus 5 dx by dt plus 3 x squared is equal to sine 2t plus 3 cos 2t can be converted to d2y by dt squared plus 5 dy by dt plus 6y is equal to 2 sine 2t plus 6 cos 2t, and solve the differential equation to find x in terms of t. All right, so let's start. So we have y is equal to x squared. Then I can say dy by dx is equal to 2x. All right, what I actually need is dx by dt, so maybe I should go a different route. I need dx by dt. I could have continued, but let's try this different route. To say that x is equal to the square root of y, or y to the half power. Now, dx by dy is a half y to the minus a half, or 1 over 2y to the half power. All right, that's dx by dy, but I need dx by dt. So this would be dx by dy times dy by dt. So dx by dy is 1 over 2y raised to the half power dy by dt. So now next I need or this is 1/2 y to the minus a half dy by dt. Now let's get d2x by dt squared. So of course, I'm going to differentiate dx by dt one more time with respect to t. So it becomes, this is a product derivative. So I'm differentiating this now with respect to t. It's a product derivative. So it is leave the first. Differentiate the second. Plus differentiate the first. So it's minus, plus a half times minus a half y to the 3 over 2. And we need to differentiate y with respect to t. We get what? dy by dt. Leave the second, which is what? dy by dt. So we could simplify to 1 over 2 1 over 2y to the half d2y by dt squared minus a quarter, this should have been negative up here, 4y to the 3 over 2, dy by dt, and this is squared. So we're asked to show that all right, so we're asked to show that that x d2 x by dt squared plus dx by dt all squared plus 5x dx by dt plus 3x squared is equal to sine 2t plus 3 cos 2t can become something else. So let's do our substitutions. Can become a differential equation where you have y in it instead of x. So if we do our substitution, we're going to have x d2x by dx squared. But remember, x is equal to y to the half power. So x, which is y to the half power, d2 x by dt squared, which is 1 over 2 y to the half, d2y by dt squared, minus 1 over 4y to the 3 over 2, dy by dt squared plus 5x, which is what? Y to the half, dx by dt, and dx by dt is 1 over 2 y to the half, dy by dt plus 3x squared. Remember that x squared is equal to y, so this is 3y is equal to sine 2t plus 3 cos 2t. Simplifying, we're going to get d2y. There's a half there. All right. A half d2y by dt squared minus 1 over 4y dy by dt squared plus 5 over 2 dy by dt. No, something is missing. Something is missing. What is missing is this. It's missing from here. So let's put it in. All right, so this is plus dx by dt squared. So dx by dt is 1 over 2y to the half. And then we have dy by dt squared plus 5x, which is y to the half, dx by dt, which is 1 over 2y to the half, dy by dt, plus 3x squared, which is 3y, is equal to sine 2t plus 3 cos 2t. All right, so erasing here, we have plus 1 over 4y dy by dt square plus 5 dy by dt plus 3y is equal to sine 2t plus 3 cos 2t. All right, so this goes and we end up with what? 1 over 2 d2y by dt squared. This should be a 5 over 2. 2 should be here. So now we have what? Plus 5 over 2 dy by dt plus 6y is equal to sine 2t plus 3 cos 2t. Multiplying the entire equation by 2, and we get d2y by dt squared plus 5 dy by dt plus 6y is equal to, right, it wasn't 6 here. Sometime I jumped the gun, it should have been 2 here. Sorry, not 2, 3y here. So now it becomes 6y plus 2 sine 2t plus 3 cos 2t. All right, so now we have a second order, a non-homogeneous second order differential equation. And we're asked to solve it. So let us first find the complementary function, which is the solution to d2y by dt squared plus 5 dy by dt plus 6y is equal to 0. For that, we need the auxiliary quadratic equation, which is m squared 5m plus 6 is equal to 0. Solving, is equal to 0. So m plus 2 is equal to 0, or m plus 3 is equal to 0. M is equal to minus 2, or m is equal to minus 3 are the solutions of the auxiliary quadratic equation. So the CF would be y is equal to a e to the minus 2t plus b e to the minus 3t. Next, we need the particular integral. For the particular integral, it is of the same form as fx, so it's equal to a sine 2t plus b cos 2t, and our objective is to find a and b. Let's differentiate. We have dy by dt. Differentiate sine, you get cos, you get what? 2a cos 2t. Differentiate cos, you get minus sine, minus 2b sine 2t. Differentiate again, d2y by dt squared. Differentiate cos, you get minus sine, so it's minus 4a sine 2t minus 4b cos 2t. Substituting back into the differential equation, we're going to get, which is, the differential equation is d2y by dt squared plus 5 dy by dt plus 6y is equal to 2 sine 2t plus 6 cos 2t. Well, substituting back into that, we're going to get minus 4a sine 2t minus 4b cos 2t plus 5 open bracket 2a cos 2t minus 2b sine 2t plus 6y, which is 6a sine 2t plus b cos 2t, and this is equal to 2 sine 2t plus 6 cos 2t. All right, simplifying, we get minus 4a sine 2t plus 6a sine 2t. So that takes care of this and this. We have minus 4b cos 2t plus 6b cos 2t. That takes care of that and that, plus 5 2s are 10. 10a cos 2t minus 10b sine 2t, and this is equal to 2 sine 2t plus 6 cos 2t. So this is 2a sine 2t plus 2b, not plus, yes, it's still, it is plus 2b cos 2t plus 10a cos 2t minus 10b sine 2t is equal to 2 sine 2t plus 6 cos 2t. Now equating coefficients, we have 2a minus 10b is equal to 2, and this is the sine 2t coefficient. And we have 2b plus 10a. 2b plus 10a is equal to 6. And this is the sine, sorry, not sine, the cos 2t coefficient. All right, so multiplying equation 1 by 5, we get 10a minus 50b is equal to 10. So it's equation 1 by 5. And we have 10a plus 2b is equal to 6. Subtract And we get, back up, and if we subtract, we're going to get minus 52b is equal to 4. And so b is equal to minus 4 over 52, which is minus 1 over 13. So that's B. Let's get A. So back to equation 1. 2A minus 10 times minus 1 over 13 is equal to 2. This is equation 1. We're going to get 2A plus 10 over 13 is equal to 2. 2A is equal to 2 minus 10 over 13. I think this is going to work out to be 6 over 13. And A, if we divide both sides by 2, would be equal to 3 over 13. So let's see if we did something wrong. All right, this is definitely a plus. Goes over and become a minus. Okay. Here's where we went wrong. This should have been 16 over 13. And 16 divided by 2, this should be 8. So now that we have A and B, we could say that our general solution is, this is in terms of what? Our general solution is y. Y is equal to A e to the minus 2t plus B e to the minus 3t plus 8 over 13 sine 2t minus 1 over 13 cos 2t. But initially, we're asked to solve the differential equation to find x in terms of t. What we have is y in terms of t, but y is actually equal to x squared. So I can take out y and say x squared is equal to a e to the minus 2t plus b e to the minus 3t plus 8 over 13 sine 2t minus 1 over 13, the cos of 2t is the general solution of this differential equation.